Question 1. Investigation of a recurring wireless network performance degradation issue in a U.S.-based enterprise reveals that users are experiencing intermittent connectivity drops and slow data speeds. During troubleshooting, a network engineer considers adjusting access point transmit power to improve signal coverage. Which of the following actions best aligns with U.S. regulatory compliance requirements for wireless network operation? Option A. Assume that the performance issues are solely due to network congestion and focus on optimizing client device configurations without checking regulatory compliance. Option B. Verify that the access points are configured to operate on authorized channels and within the maximum transmit power limits specified by the FCC for the deployed frequency bands. Option C. Immediately increase the transmit power of all access points in the affected areas to their maximum allowable hardware settings to boost signal strength. Option D. Temporarily disable certain access points to reduce channel utilization, without first confirming that the remaining access points are operating within FCC power and channel restrictions. The correct answer is B. Verify that the access points are configured to operate on authorized channels and within the maximum transmit power limits specified by the FCC for the deployed frequency bands. Explanation. The scenario presents a common challenge in enterprise wireless networks, ensuring compliance with regulatory requirements for radio frequency emissions and spectrum usage, particularly when troubleshooting performance issues. The challenge lies in balancing the need for network functionality and user experience with the legal obligation to operate within designated frequency bands and power limits. Failure to adhere to these regulations can result in significant penalties, including fines and operational disruption. The correct approach involves a systematic investigation that prioritizes regulatory compliance. This means verifying that the wireless infrastructure is configured and operating within the parameters defined by the relevant regulatory bodies. Specifically, for the U.S. jurisdiction, this would involve consulting FCC, Federal Communications Commission, regulations. The correct approach would be to use diagnostic tools to confirm that the deployed access points are operating on authorized channels within permitted power levels and are not causing harmful interference to other licensed services. This proactive verification ensures that troubleshooting efforts are not inadvertently exacerbating or causing regulatory violations. An incorrect approach would be to solely focus on performance metrics without considering the underlying regulatory framework. For instance, attempting to increase transmit power to overcome signal degradation without first verifying that such an increase is permissible under FCC Part 15 rules would be a regulatory failure. This could lead to interference with other devices or services, resulting in complaints and potential enforcement actions by the FCC. Another incorrect approach would be to ignore or dismiss reported interference issues as user error or minor network anomalies, without investigating potential regulatory breaches. This demonstrates a lack of due diligence and a disregard for the legal obligations associated with operating wireless spectrum. Professionals should adopt a decision-making process that integrates regulatory awareness into every troubleshooting step. This involves 1. Understanding the applicable regulatory framework, e.g., FCC rules in the U.S. 2. Identifying potential regulatory compliance issues during initial problem assessment. 3. Utilizing diagnostic tools to verify compliance with channel, power, and interference limits. 4. Prioritizing remediation of any identified regulatory noncompliance before or in conjunction with performance tuning. 5. Documenting all findings and actions taken, including verification of regulatory adherence. This structured approach ensures that network operations are not only efficient but also legally sound. Question 2. What factors determine the most effective troubleshooting approach for intermittent wireless connectivity issues in an enterprise network, considering potential regulatory implications? Option A. The cost of potential hardware replacements and the time elapsed since the last network upgrade. Option B. The urgency of the reported issue and the number of users experiencing the problem. Option C. The perceived complexity of the wireless network architecture and the availability of advanced diagnostic tools. Option D. The likelihood and potential impact of various failure points, including environmental interference, configuration errors, and hardware malfunctions. The correct answer is D. The likelihood and potential impact of various failure points, including environmental interference, configuration errors, and hardware malfunctions. Explanation: the scenario involves troubleshooting a wireless network experiencing intermittent connectivity issues, which can significantly impact business operations and user productivity. The challenge lies in identifying the root cause among numerous potential factors, ranging from physical layer problems to configuration errors and interference. A systematic and risk-based approach is crucial to efficiently resolve the issue while minimizing downtime and potential data loss. Regulatory compliance in wireless networking, particularly concerning spectrum usage and security, adds another layer of complexity, as misconfigurations or unaddressed vulnerabilities could lead to non-compliance and associated penalties. The correct approach, focusing on a risk assessment of potential causes, represents best professional practice because it prioritizes troubleshooting efforts based on the likelihood and impact of each potential issue. This aligns with general IT best practices for incident management, which emphasize efficient resource allocation and minimizing business disruption. From a regulatory perspective, a risk-based approach helps ensure that critical security and operational parameters are addressed first, thereby mitigating risks of noncompliance with relevant wireless regulations, e.g., FCC Part 15 in the U.S. for unlicensed spectrum usage, or specific data privacy regulations that might be impacted by network instability. By systematically evaluating risks, a troubleshooter can ensure that actions taken are not only effective, but also compliant with any applicable standards or laws governing network operation and data integrity. An incorrect approach that solely focuses on changing the most recently implemented configuration without assessing its potential impact or likelihood of causing the problem is professionally unacceptable. This could lead to further network instability and is a violation of sound troubleshooting methodologies. Ethically, it demonstrates a lack of due diligence and could be seen as negligent if it exacerbates the issue. From a regulatory standpoint, blindly altering configurations without understanding their implications could inadvertently lead to noncompliance with spectrum management rules or security protocols. Another incorrect approach, such as immediately replacing hardware without thorough diagnostics, is also professionally flawed. This is wasteful, time-consuming, and bypasses the systematic problem-solving required for effective troubleshooting. It fails to consider that the issue might be software-related or environmental. Regulatory failures here could arise if the replaced hardware is not disposed of properly, or if the hasty replacement leads to the introduction of non-compliant equipment. Finally, an approach that ignores potential interference sources and focuses only on internal network settings is incomplete and unprofessional. Wireless environments are inherently susceptible to external factors. Failing to consider these risks means the troubleshooting process is not comprehensive. This can lead to prolonged downtime and, from a regulatory perspective, could result in continued noncompliance with spectrum etiquette if interference is the root cause and is left unaddressed. The professional decision-making process for similar situations should involve a structured incident response plan. This typically includes 1. Incident identification and scoping. Clearly define the problem and its impact. 2. Information gathering. Collect logs, user reports, and network status. 3. Risk assessment. Prioritize potential causes based on likelihood and impact. 4. Hypothesis generation and testing. Formulate educated guesses and test them systematically. 5. Resolution and verification. Implement the fix and confirm the issue is resolved. 6. Documentation and prevention. Record the incident and identify measures to prevent recurrence. This framework ensures a methodical, efficient, and compliant resolution. Question 3. When evaluating the cause of intermittent wireless connectivity issues impacting a critical business application, which troubleshooting approach best mitigates potential risks to network security and operational continuity? Option A. Temporarily disable wireless security protocols to simplify connectivity testing and isolate the issue to the network infrastructure. Option B. Immediately reboot all wireless access points in the affected area to clear any temporary glitches and restore service quickly. Option C. Systematically analyze network logs and traffic patterns to identify anomalies, and then assess the potential impact of diagnostic steps on security and performance before implementation. Option D. Implement broad configuration changes across the wireless controller based on common troubleshooting advice found online. The correct answer is C. Systematically analyze network logs and traffic patterns to identify anomalies, and then assess the potential impact of diagnostic steps on security and performance before implementation. Explanation: this scenario presents a professional challenge because a wireless network outage directly impacts business operations, potentially leading to financial losses and reputational damage. The urgency to restore service must be balanced with a methodical, risk-aware approach to troubleshooting. Rushing to implement solutions without understanding the root cause can introduce new problems or exacerbate existing ones, leading to further downtime and increased complexity. A thorough risk assessment is crucial to prioritize actions, allocate resources effectively, and ensure that the chosen troubleshooting steps do not introduce new security vulnerabilities or compliance issues. The correct approach represents best professional practice because it systematically identifies potential risks associated with troubleshooting actions and prioritizes those that pose the greatest threat to the network's integrity and the organization's operations. This aligns with general IT best practices, and by extension, the principles of responsible network management that underpin regulatory compliance in enterprise environments. By considering the impact of each troubleshooting step on security, performance, and compliance, the network administrator ensures that the resolution process is not only effective, but also minimizes collateral damage and adheres to established operational standards. This proactive risk management is essential for maintaining a stable and secure network infrastructure. An incorrect approach that involves immediately rebooting all access points without diagnosis fails to consider the potential for data loss or corruption if the underlying issue is related to configuration or a critical service. This could lead to a violation of data integrity principles, which are often implicitly or explicitly covered by data protection regulations. Another incorrect approach, such as disabling security features to speed up connectivity tests, directly contravenes security best practices and could expose the network to unauthorized access, violating security mandates and potentially leading to breaches that have significant regulatory consequences. A third incorrect approach, which involves making extensive configuration changes based on anecdotal evidence from other networks, ignores the specific context of the current environment and could introduce incompatibilities or unintended side effects, leading to further instability and potential compliance issues if critical services are affected. Professionals should employ a structured decision-making process that begins with a clear understanding of the problem's impact. This involves gathering information, identifying symptoms, and then performing a risk assessment of potential troubleshooting steps. The assessment should consider the likelihood of success, the potential negative impacts, including security, performance, and compliance, and the resources required. Prioritizing actions based on this assessment, starting with non-disruptive diagnostic steps and progressing to more impactful interventions only when necessary and with appropriate safeguards, is key to effective and responsible troubleshooting. Question 4. Compliance review shows that the current risk assessment process for the enterprise wireless network may not adequately address the potential exposure of sensitive customer data transmitted wirelessly. Which of the following actions best represents a professional and compliant approach to remediate this finding? Option A. Implement a strict policy to prohibit the transmission of any sensitive customer data over the wireless network until a new security solution can be identified. Option B. Immediately upgrade all wireless access points to the latest hardware model to ensure the most advanced wireless security features are deployed across the network. Option C. Adopt the default security configurations recommended by the wireless equipment vendor without further internal analysis. Option D. Conduct a comprehensive reevaluation of the wireless network's risk assessment methodology, identifying all sensitive data types, mapping their transmission paths, and implementing enhanced security controls based on identified vulnerabilities. The correct answer is D. Conduct a comprehensive reevaluation of the wireless network's risk assessment methodology, identifying all sensitive data types, mapping their transmission paths, and implementing enhanced security controls based on identified vulnerabilities. Explanation: scenario analysis. A compliance review has identified potential vulnerabilities in the wireless network's risk assessment process, specifically concerning the handling of sensitive data transmitted over the air. This scenario is professionally challenging because a flawed risk assessment can lead to inadequate security controls, potentially resulting in data breaches, regulatory fines, and reputational damage. The complexity arises from balancing robust security with network performance and user experience, all while adhering to evolving regulatory landscapes. The pressure to quickly rectify the identified gaps without disrupting critical business operations adds another layer of difficulty. Correct approach analysis. The correct approach involves a systematic reevaluation of the wireless network's risk assessment methodology. This includes identifying all sensitive data types transmitted wirelessly, mapping their flow, and assessing potential threats and vulnerabilities specific to the wireless environment. Based on this, appropriate security controls such as robust encryption, e.g., WPA3 Enterprise, strong authentication mechanisms, e.g., 802.1x with EAP-TLS, network segmentation and intrusion detection/prevention systems, WIDS/WIPS, should be implemented or strengthened. This approach aligns with best practices for data protection and regulatory compliance, ensuring that risks are identified, understood, and mitigated effectively. It demonstrates due diligence and a proactive stance towards security, which is paramount in maintaining trust and avoiding penalties. Incorrect approach is analysis. One incorrect approach is to solely focus on upgrading the wireless access points to the latest hardware without a corresponding reassessment of the risk landscape. This is a technically driven solution that may not address the root cause of the identified vulnerabilities, such as weak authentication protocols or inadequate data classification. It represents a failure to conduct a thorough risk assessment, potentially leaving critical data exposed. Another incorrect approach is to implement a blanket policy of disabling all wireless access for sensitive data transmission. While this might seem like a secure measure, it is often impractical and can severely hinder business operations. It fails to consider the nuanced nature of risk and the possibility of secure wireless transmission through appropriate controls. This approach demonstrates a lack of understanding of risk management principles, which advocate for mitigation rather than outright prohibition where feasible. A third incorrect approach is to rely solely on vendor-provided security recommendations without independent verification or tailoring them to the specific organizational context. Vendor solutions are often generic and may not account for the unique threat vectors or regulatory requirements applicable to the organization. This approach represents a failure in due diligence and a potential abdication of responsibility for the security posture of the wireless network. Professional reasoning. Professionals facing such a situation should adopt a structured, risk-based approach. First, thoroughly understand the compliance requirements and the specific nature of the sensitive data being transmitted. Second, conduct a comprehensive risk assessment that identifies assets, threats, vulnerability, and potential impacts. Third, prioritize risks based on their likelihood and impact. Fourth, develop and implement appropriate mitigation strategies, which may include technical controls, policy changes, and user training. Finally, continuously monitor and review the effectiveness of these controls and update the risk assessment as the threat landscape and business requirements evolve. This iterative process ensures that security measures remain relevant and effective. Question 5. Operational review demonstrates a potential security anomaly detected by an intrusion detection system, IDs, on the wireless network, flagging a high number of connection attempts from an unknown MAC address to sensitive internal resources. The immediate concern is a potential unauthorized access attempt. What is the most appropriate next step to address this perceived risk? Option A. Conduct a detailed forensic analysis of the IDS logs and wireless controller logs to identify the source and nature of the connection attempts, and correlate this with network traffic patterns before implementing any network-wide changes. Option B. Escalate the issue to senior management and request a temporary shutdown of all wireless services to mitigate the perceived risk. Option C. Immediately implement a broad network-wide access control list, ACL, to block all traffic originating from any unknown MAC addresses to prevent further potential intrusion. Option D. Disable all wireless access points across the enterprise until the security team can fully investigate and confirm the threat. The correct answer is A. Conduct a detailed forensic analysis of the IDS logs and wireless controller logs to identify the source and nature of the connection attempts, and correlate this with network traffic patterns before implementing any network-wide changes. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless networks where a perceived risk, such as potential unauthorized access, needs to be addressed without disrupting legitimate business operations. The difficulty lies in balancing security imperatives with the need for continuous network availability and user productivity. A hasty or overly restrictive approach could lead to significant operational downtime, user frustration, and potential business losses, while an insufficient response could leave the network vulnerable. The professional challenge is to identify the root cause of the perceived risk and implement a targeted, effective, and proportionate solution. Correct approach analysis. The correct approach involves a systematic investigation to validate the initial risk assessment. This means gathering concrete evidence to determine if the perceived threat is real, its scope, and its potential impact. Implementing a solution based on validated data, such as a targeted policy change or a specific configuration adjustment, is best professional practice. This aligns with the principles of risk management, which emphasize data-driven decision-making and proportionate responses. In the context of Cisco wireless enterprise networks, this would involve leveraging diagnostic tools and logs to pinpoint the source of the issue and apply the most efficient fix, thereby minimizing disruption and ensuring compliance with operational security policies. Incorrect approaches analysis. Implementing a broad, network-wide access control list, ACL, without prior investigation is an incorrect approach. This is because it assumes the risk is pervasive and applies a blanket solution that could inadvertently block legitimate traffic, leading to operational failures and user complaints. Ethically, it fails to uphold the principle of proportionality and risk mitigation. Disabling all wireless access points until the issue is resolved is also an incorrect approach. This represents an extreme and disproportionate response that would cause significant business disruption. It demonstrates a failure in risk assessment by not considering the impact of a complete outage and prioritizes an absolute, but impractical, security stance over operational continuity. Ignoring the initial report and continuing with normal operations is an incorrect approach. This demonstrates a failure to acknowledge and address potential security vulnerabilities, which could lead to a breach. Ethically, it violates the duty to protect network resources and user data, potentially leading to regulatory noncompliance if data protection laws are breached. Professional reasoning. Professionals should adopt a structured approach to troubleshooting and risk management. This involves 1. Acknowledging and documenting the reported risk. 2. Initiating a diagnostic phase to gather evidence and validate the risk. 3. Analyzing the evidence to determine the root cause and potential impact. 4. Developing and implementing a targeted solution that addresses the validated risk while minimizing operational disruption. 5. Verifying the effectiveness of the solution and documenting the resolution. This systematic process ensures that decisions are informed, proportionate, and aligned with both security best practices and business objectives. Question 6. Governance review demonstrates a potential security risk stemming from unauthorized access points detected within the enterprise wireless network. Which troubleshooting approach best aligns with addressing this specific governance finding while minimizing operational impact? Option A. Immediately disable all wireless access points and initiate a full network firmware upgrade to the latest stable version to ensure all devices are compliant. Option B. Conduct a comprehensive wireless network security audit, focusing on rogue access point detection and mitigation, and then analyze network performance logs for any anomalies that may have facilitated the unauthorized access. Option C. Implement a broad network segmentation policy across the entire wired and wireless infrastructure without first identifying the specific source or impact of the unauthorized access points. Option D. Focus troubleshooting efforts on improving overall wireless signal strength and reducing client connection errors, as these are common user complaints. The correct answer is B. Conduct a comprehensive wireless network security audit, focusing on rogue access point detection and mitigation, and then analyze network performance logs for any anomalies that may have facilitated the unauthorized access. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless networks where a recent governance review has identified potential risks related to the security posture of the wireless infrastructure. The challenge lies in translating a high-level governance finding into actionable troubleshooting steps that address the root cause of the risk without causing undue disruption to business operations. The pressure to remediate quickly, coupled with the need to maintain network availability and performance, requires a systematic and risk-aware approach. The complexity of wireless protocols, potential interference, and the distributed nature of access points add layers of difficulty to accurate diagnosis and resolution. Correct approach analysis. The correct approach involves a structured risk assessment directly tied to the governance findings. This means first understanding the specific vulnerabilities or non-compliance issues highlighted by the review. Subsequently, a targeted investigation of the wireless network's configuration, security settings, and operational logs is initiated, prioritizing areas identified as high risk. This approach is best professional practice because it aligns troubleshooting efforts with organizational governance objectives and regulatory compliance requirements. By focusing on the identified risks, IT professionals can efficiently allocate resources, minimize the scope of investigation, and ensure that remediation directly addresses the governance concerns. This proactive and evidence-based methodology prevents unnecessary downtime and ensures that security and compliance are maintained, which is paramount in regulated environments. Incorrect approaches analysis. A generalized network performance tuning approach, without first addressing the specific governance findings, is professionally unacceptable. This fails to directly tackle the identified risks, potentially leaving the organization exposed to the very vulnerabilities the governance review sought to mitigate. It represents a failure to adhere to established governance frameworks and could lead to non-compliance with internal policies and potentially external regulations if the governance review was driven by such requirements. Implementing a broad, system-wide configuration rollback without a precise understanding of the impact on the identified risks is also professionally unsound. This approach is reactive and lacks the precision required for effective troubleshooting. It risks introducing new vulnerabilities or disrupting critical services, demonstrating a disregard for operational stability and a failure to conduct a proper risk assessment before making significant changes. This can lead to regulatory breaches if the rollback inadvertently compromises security controls mandated by compliance standards. Focusing solely on user-reported issues without correlating them to the governance findings is another professionally deficient approach. While user experience is important, it may not directly reflect the systemic risks identified by governance. This approach risks treating symptoms rather than the underlying causes of the governance concerns, leading to a superficial fix that does not resolve the core problem and leaves the organization vulnerable. It indicates a lack of understanding of the governance mandate and a failure to prioritize remediation efforts effectively. Professional reasoning. Professionals should adopt a decision-making process that begins with a thorough understanding of the governance review's findings and their implications. This involves identifying the specific risks and compliance requirements. The next step is to translate these findings into a targeted troubleshooting plan that prioritizes the highest risk areas. This plan should include a risk assessment of potential troubleshooting actions, considering their impact on network availability and security. Continuous monitoring and validation of remediation efforts against the original governance findings are crucial. This systematic, risk-informed, and compliance-aware approach ensures that troubleshooting is effective, efficient, and aligned with organizational objectives. Question 7. The performance metrics show a consistent but slight increase in packet loss and latency on the wireless network over the past 48 hours, impacting user experience during peak hours, but the issue is not reproducible during off-peak times or with wired connections. What is the most appropriate initial risk assessment and troubleshooting approach? Option A. Immediately schedule a full network hardware refresh, including all wireless access points and controllers, to proactively address potential aging infrastructure issues. Option B. Initiate a phased risk assessment, prioritizing immediate user impact mitigation through targeted wireless controller and access point configuration review, while simultaneously planning for deeper packet capture and analysis during peak hours to identify the root cause. Option C. Advise users to avoid using the wireless network during peak hours until a comprehensive network-wide diagnostic can be performed, which may take several weeks. Option D. Document the intermittent nature of the issue and inform management that no immediate action is required until the problem becomes more severe and consistently reproducible. The correct answer is B. Initiate a phased risk assessment, prioritizing immediate user impact mitigation through targeted wireless controller and access point configuration review, while simultaneously planning for deeper packet capture and analysis during peak hours to identify the root cause. Explanation: scenario analysis. This scenario presents a common challenge in wireless network troubleshooting: intermittent performance degradation that is difficult to pinpoint. The difficulty lies in the transient nature of the issue, making it hard to capture definitive evidence. The pressure to restore full functionality quickly, coupled with the potential impact on business operations, necessitates a systematic and well-justified approach to risk assessment. The challenge is to balance the urgency of resolution with the need for thorough investigation to prevent recurrence and ensure compliance with service-level agreements, SLAs, and potentially regulatory requirements for network availability and data integrity. Correct approach analysis. The correct approach involves a phased risk assessment that prioritizes immediate mitigation while planning for deeper root cause analysis. This aligns with best professional practices by acknowledging the immediate impact on users and business operations. It demonstrates a commitment to service restoration, a key ethical and professional obligation. By documenting the initial findings and the rationale for the chosen mitigation strategy, it establishes a clear audit trail, which is crucial for accountability and future troubleshooting. This approach also implicitly considers the potential for regulatory noncompliance if the network issues were to impact critical services or data security, by taking proactive steps to address the problem. Incorrect approaches analysis. One incorrect approach involves immediately escalating to a complete network overhaul without sufficient data. This is professionally unsound because it represents a significant, potentially unnecessary expenditure of resources and could introduce new, unforeseen issues. Ethically, it fails to demonstrate due diligence in investigating the actual problem, potentially violating principles of responsible resource management. From a regulatory perspective, such a drastic measure without clear justification could be seen as a failure to adhere to prudent operational practices, especially if it leads to prolonged downtime or service disruption that breaches contractual obligations or regulatory mandates for service continuity. Another incorrect approach is to dismiss the reported issues due to a lack of immediate, easily reproducible evidence. This is professionally negligent as it ignores user reports and potential underlying problems that, while intermittent, could be indicative of more serious systemic failures. Ethically, it demonstrates a lack of commitment to user satisfaction and service quality. Regulatory failure here could manifest as a breach of SLAs or, in certain sectors, a failure to maintain a secure and reliable network infrastructure, potentially leading to data loss or security vulnerabilities that have regulatory implications. A third incorrect approach is to implement a series of uncoordinated ad hoc fixes without a structured risk assessment. This is professionally chaotic and inefficient, leading to wasted effort and a higher likelihood of incomplete resolution. It undermines the principles of systematic troubleshooting and problem solving. Ethically, it shows a lack of professional rigor and accountability. Regulatory failure can occur if these uncoordinated fixes inadvertently compromise network security, data integrity, or service availability, leading to noncompliance with industry standards or legal requirements. Professional reasoning. Professionals should approach such situations by first gathering all available data, including performance metrics, user reports, and historical logs. This data should then be used to conduct an initial risk assessment, categorizing the potential impact of the issue on business operations and compliance. Based on this assessment, a prioritized plan should be developed, starting with immediate, low-risk mitigation strategies to restore service as quickly as possible. Simultaneously, a plan for deeper investigation to identify the root cause should be initiated, with clear objectives and timelines. Throughout this process, thorough documentation of all actions, findings, and decisions is paramount for accountability, knowledge sharing, and demonstrating due diligence. Question 8. The evaluation methodology shows a critical wireless network outage impacting multiple departments. The network administrator must determine the most appropriate risk assessment approach to guide the troubleshooting process, considering the potential for further disruption and security implications. Which of the following risk assessment approaches would best align with professional best practices for troubleshooting in this scenario? Option A. Focus troubleshooting efforts solely on the most visible symptoms of the outage, assuming a direct correlation to the root cause. Option B. Defer detailed risk assessment until after the network is fully restored to avoid delaying the resolution process. Option C. Prioritize troubleshooting actions based on a systematic evaluation of their potential impact on network stability and security, alongside the likelihood of their success in resolving the issue. Option D. Immediately implement all known troubleshooting steps for common wireless issues to expedite service restoration, without detailed risk analysis for each step. Correct answer is C. Prioritize troubleshooting actions based on a systematic evaluation of their potential impact on network stability and security, alongside the likelihood of their success in resolving the issue. Explanation. The evaluation methodology shows a scenario where a wireless network's performance degradation is impacting critical business operations, necessitating a rapid and effective troubleshooting approach. The professional challenge lies in balancing the urgency of restoring service with the need to adhere to established risk assessment protocols, ensuring that troubleshooting actions do not inadvertently introduce new security vulnerabilities or violate compliance mandates. This requires a systematic approach that prioritizes potential impacts and allocates resources judiciously. The correct approach represents best professional practice because it aligns with the principles of proactive risk management and incident response. By first identifying and categorizing potential risks associated with different troubleshooting actions, a network engineer can make informed decisions about the sequence and scope of their interventions. This methodology ensures that high-impact, low-probability risks are addressed with appropriate caution, while more common or lower-impact risks are managed efficiently. This systematic risk assessment is crucial for maintaining network integrity and compliance with industry best practices for network security and operational stability. An incorrect approach that involves immediately implementing all potential fixes without prior risk assessment fails to acknowledge the potential for unintended consequences. This could lead to further network instability, data breaches, or service disruptions, which would be a direct violation of operational security policies and potentially regulatory requirements for data protection and service availability. Another incorrect approach, focusing solely on the most obvious symptoms without considering underlying systemic risks, can lead to superficial fixes that do not address the root cause, prolonging the outage and increasing the overall business impact. This demonstrates a lack of due diligence and a failure to apply a comprehensive troubleshooting framework, which could be seen as professional negligence. A third incorrect approach, prioritizing speed over thoroughness by skipping documentation and verification steps, undermines auditability and future troubleshooting efforts, potentially leading to repeated issues and a failure to meet service-level agreements, which can have contractual and regulatory implications. A professional decision-making process for similar situations should involve a structured risk assessment framework. This includes identifying potential troubleshooting actions, evaluating the likelihood and impact of each action on network stability, security, and business operations, and then prioritizing actions based on this risk profile. Documenting all steps taken and their outcomes is essential for accountability, knowledge sharing, and compliance. Question 9. Cost-benefit analysis shows that implementing a new, more aggressive RF channel scanning algorithm on the enterprise wireless network could potentially improve client roaming performance and reduce interference. However, this change has not been thoroughly tested in a production environment, and there are concerns about its impact on existing client devices and overall network stability. What is the most professionally responsible approach to address intermittent client connectivity issues that have recently emerged, given these considerations? Option A. Immediately roll back recent network configuration changes that coincided with the emergence of connectivity issues, and then systematically reintroduce them while monitoring for the problem. Option B. Conduct a thorough analysis of existing network logs, client-side event data, and environmental factors to identify the root cause of the intermittent connectivity before considering any significant configuration changes. Option C. Focus troubleshooting efforts solely on the client devices experiencing connectivity issues, assuming the wireless infrastructure is functioning optimally. Option D. Proceed with deploying the new RF channel scanning algorithm across the entire network, as the potential benefits outweigh the perceived risks, and it is the most advanced solution available. The correct answer is D. Proceed with deploying the new RF channel scanning algorithm across the entire network, as the potential benefits outweigh the perceived risks, and it is the most advanced solution available. Explanation. This scenario presents a common challenge in enterprise wireless troubleshooting, balancing immediate operational needs with long-term network stability and security. The professional challenge lies in discerning the root cause of intermittent client connectivity issues without disrupting critical business operations or introducing new vulnerabilities. A hasty or incomplete troubleshooting approach can lead to misdiagnosis, wasted resources, and potentially more severe network degradation. The correct approach represents best professional practice because it prioritizes a systematic and data-driven methodology by first gathering comprehensive network and client-side logs, and then correlating this data with known environmental factors and recent configuration changes. A technician can accurately pinpoint the source of the problem. This aligns with industry best practices for network management and troubleshooting, which emphasize thorough investigation before implementing solutions. Furthermore, adhering to established change management procedures, even during troubleshooting, ensures that any remediation steps are documented, reviewed, and have a minimal impact on network availability, thereby upholding professional responsibility and minimizing risk. An incorrect approach that immediately resorts to broad, sweeping configuration changes without a clear understanding of the root cause is professionally unacceptable. Such actions can introduce unintended consequences, such as disrupting other services, creating security loopholes, or masking the original issue, making future diagnosis more difficult. This demonstrates a failure to apply due diligence and a disregard for the potential negative impacts on the network and its users. Another incorrect approach, focusing solely on client-side issues while ignoring potential infrastructure problems, is also flawed. This selective troubleshooting can lead to prolonged downtime and user frustration, as the actual problem may lie within the wireless infrastructure itself. Ethically, professionals are expected to conduct a comprehensive investigation rather than making assumptions. The professional decision-making process for similar situations should involve a structured approach. 1. Define the problem clearly, including its scope and impact. 2. Gather all relevant data from various sources, logs, monitoring tools, user reports. 3. Formulate hypotheses based on the gathered data. 4. Test hypotheses systematically, starting with the least intrusive methods. 5. Implement solutions based on confirmed root causes, following change management protocols. 6. Verify the resolution and document the process. This methodical approach ensures that troubleshooting is efficient, effective, and minimizes risk. Question 10. The risk matrix shows a critical vulnerability related to WPA3 handshake encryption on a segment of the wireless network, yet no user-reported issues are currently associated with this specific vulnerability. The network operations team is also dealing with several high-priority user tickets, reporting intermittent connectivity and slow performance on other network segments. What is the most appropriate course of action for the wireless network administrator? Option A. Prioritize resolving the user-reported intermittent connectivity and slow performance issues, as these are actively impacting users and generating immediate support requests. Option B. Implement a temporary workaround for the WPA3 handshake vulnerability, such as disabling WPA3 on the affected segment, and then address the user-reported issues. Option C. Immediately schedule and implement the necessary configuration changes to address the WPA3 handshake encryption vulnerability, while temporarily deferring the resolution of user-reported connectivity issues to less critical maintenance windows. Option D. Document the WPA3 vulnerability and add it to the backlog for future review during the next scheduled network upgrade cycle. The correct answer is C. Immediately schedule and implement the necessary configuration changes to address the WPA3 handshake encryption vulnerability, while temporarily deferring the resolution of user-reported connectivity issues to less critical maintenance windows. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless troubleshooting, balancing immediate operational needs with long-term security and compliance. The risk matrix highlights a critical vulnerability that, if exploited, could lead to significant data breaches and service disruptions. The professional challenge lies in prioritizing remediation efforts when multiple issues demand attention, especially when the immediate impact of the identified vulnerability is not yet apparent to end users. Failure to act decisively could result in regulatory penalties, reputational damage, and financial losses, all of which are serious considerations within the scope of enterprise network management. Correct approach analysis. The correct approach prioritizes addressing the identified critical vulnerability on the risk matrix. This aligns with best professional practices in cybersecurity and network management, emphasizing a proactive stance against potential threats. Within the regulatory framework governing enterprise networks, assuming a U.S. jurisdiction for this example, as per common exam contexts, organizations have a duty of care to protect sensitive data and ensure network integrity. Promptly mitigating high-risk vulnerabilities is a fundamental requirement to comply with regulations like HIPAA for healthcare data, PCI DSS for payment card data, or general data privacy laws that mandate reasonable security measures. This approach demonstrates due diligence and a commitment to maintaining a secure and compliant network environment, preventing potential incidents before they occur. Incorrect approaches analysis. One incorrect approach is to defer remediation of the critical vulnerability because it has not yet been actively exploited. This is a reactive and negligent stance that violates the principle of proactive security. Ethically and regulatorily, organizations are expected to address known risks, not wait for an incident to occur. This approach could lead to severe penalties under data breach notification laws and privacy regulations if a breach does happen due to the unaddressed vulnerability. Another incorrect approach is to focus solely on user-reported issues that cause minor disruptions, while ignoring the critical vulnerability. While user experience is important, it should not supersede the mitigation of significant security risks. This approach demonstrates a misallocation of resources and a failure to understand the potential cascading effects of a security breach, which can far outweigh the impact of intermittent connectivity issues. It also fails to meet the due diligence expected under cybersecurity frameworks and could be seen as a dereliction of duty in protecting organizational assets and data. A third incorrect approach is to implement a temporary workaround without a clear plan for permanent remediation. While temporary fixes can be useful in the short term, relying on them indefinitely for critical vulnerabilities leaves the network exposed. This approach lacks a strategic vision for security posture improvement and may not fully address the root cause of the vulnerability, potentially leading to its reemergence or exploitation through other means. It also fails to meet the ongoing compliance requirements for robust security controls. Professional reasoning. Professionals should employ a risk-based approach to troubleshooting and remediation. This involves understanding the potential impact and likelihood of various issues, as represented by a risk matrix. When a critical vulnerability is identified, the immediate priority should be its mitigation, even if it doesn't currently affect end users. This proactive stance is essential for maintaining network security, ensuring regulatory compliance, and protecting the organization from significant financial and reputational damage. A structured incident response plan, coupled with regular security assessments and vulnerability management, forms the bedrock of effective enterprise network management. Decision-making should be guided by a thorough understanding of the organization's security policies, relevant legal and regulatory obligations, and the potential consequences of inaction. Question 11. Quality control measures reveal a recurring pattern of intermittent wireless connectivity issues reported by users in a specific building zone. Users describe brief periods where their devices lose network access, but the connection typically restores itself within a minute. Network administrators have not identified any widespread network outages or configuration changes that coincide with these reports. What is the most effective best practice approach to diagnose and resolve these intermittent connectivity problems? Option A. Focus exclusively on updating the firmware on all client devices within the affected zone, assuming the issue is a widespread client-side compatibility problem. Option B. Immediately replace all access points in the affected zone, as hardware failure is the most probable cause of intermittent connectivity. Option C. Instruct users to reboot their devices whenever they experience connectivity issues and document the frequency of these reboots. Option D. Initiate a comprehensive packet capture on a representative sample of affected client devices and on access points serving the affected zone, while simultaneously reviewing wireless controller logs for any client disassociation events or RF anomalies during the reported timeframes. The correct answer is D. Initiate a comprehensive packet capture on a representative sample of affected client devices and on access points serving the affected zone, while simultaneously reviewing wireless controller logs for any client disassociation events or RF anomalies during the reported timeframes. Explanation: scenario analysis. This scenario presents a common challenge in enterprise wireless troubleshooting: intermittent client connectivity issues that are difficult to reproduce and diagnose. The difficulty lies in the transient nature of the problem, making it hard to capture relevant data at the precise moment of failure. This requires a systematic and thorough approach to data collection and analysis, as well as an understanding of potential root causes that span multiple layers of the OSI model. The pressure to resolve the issue quickly for end users adds to the professional challenge, demanding efficient yet accurate troubleshooting. Correct approach analysis. The correct approach involves a multifaceted strategy that prioritizes data collection and correlation, beginning with a review of the wireless controller logs for any reported client disassociation events or radio frequency (RF) anomalies during the reported timeframes is crucial. Simultaneously, initiating a packet capture on the affected client and a nearby access point app allows for the observation of actual traffic flow and potential errors. Analyzing these captures for retransmissions, dropped packets, or unexpected protocol behavior provides direct evidence of connectivity problems. Correlating these findings with the controller logs helps pinpoint whether the issue is RF-related, configuration-based, or a client-side problem. This methodical, layered approach aligns with best practices for network troubleshooting, ensuring that all potential causes are investigated systematically and that conclusions are data-driven. This is essential for maintaining network integrity and user productivity, which are implicit requirements of any enterprise IT service. Incorrect approaches analysis. Focusing solely on client-side issues without examining the wireless infrastructure is a significant oversight. This approach risks misdiagnosing the problem as a client hardware or software fault when the root cause might be poor RF coverage, AP misconfiguration, or network congestion. This failure to consider the broader network environment is a regulatory and ethical lapse, as it can lead to wasted resources and prolonged downtime for users, failing to meet the implicit service level expectations of an enterprise network. Another incorrect approach is to only review AP logs without correlating them with client-side behavior or controller events. While AP logs can indicate RF conditions or client associations, they do not provide the full picture of the client's experience or the network's response to client traffic. This limited scope can lead to incorrect conclusions and an inability to identify subtle issues like intermittent interference or authentication problems that manifest at the client level. This is a failure in due diligence and professional responsibility to thoroughly investigate. Finally, immediately replacing hardware without sufficient diagnostic data is an inefficient and potentially costly approach. While hardware failure is a possibility, it should be the last resort after all other troubleshooting steps have been exhausted. This approach bypasses the critical analysis required to understand the problem's root cause and can lead to unnecessary expenditure and further disruption if the underlying issue is not hardware-related. This demonstrates a lack of systematic problem-solving and can be seen as a failure to act in the best interest of the organization's resources. Professional reasoning. Professionals should adopt a structured troubleshooting methodology, often referred to as the OSI model approach, starting from the physical layer and moving upwards. This involves gathering information, forming hypotheses, testing those hypotheses with data, and iteratively refining the diagnosis. In wireless troubleshooting, this means considering RF, physical security, data link, network transport, and application layers. When faced with intermittent issues, the key is to maximize data capture during potential problem windows and to correlate data from multiple sources, clients, app, controllers, network devices. This systematic data-driven approach ensures that the most likely root cause is identified efficiently and effectively, minimizing downtime and ensuring the reliability of the wireless network. Question 12. Risk assessment procedures indicate that intermittent wireless connectivity issues are impacting user productivity across multiple departments. The IT team has received numerous complaints regarding slow performance and dropped connections. What is the most professional and effective approach to troubleshoot and resolve these issues? Option A. Rely on the IT team's past experience with similar issues and apply the previously successful resolution steps without conducting current diagnostics. Option B. Focus troubleshooting efforts exclusively on end-user devices, checking their network configurations, driver updates, and physical proximity to access points, as the problem is likely client-side. Option C. Immediately dispatch technicians to replace all access points in the affected areas, assuming a widespread hardware failure based on the volume of complaints. Option D. Initiate a comprehensive network performance baseline analysis, correlating user-reported symptoms with real-time and historical data from wireless controllers, access points, and client devices, while systematically isolating potential causes through diagnostic tools and log analysis. The correct answer is D. Initiate a comprehensive network performance baseline analysis, correlating user-reported symptoms with real-time and historical data from wireless controllers, access points, and client devices, while systematically isolating potential causes through diagnostic tools and log analysis. Explanation: scenario analysis. This scenario presents a common challenge in wireless network troubleshooting where intermittent performance issues are impacting user productivity and potentially business operations. The difficulty lies in the elusive nature of the problem, making it hard to pinpoint a single cause. The pressure to restore full functionality quickly, coupled with the potential for significant business impact, necessitates a systematic and evidence-based approach. Without a structured methodology, troubleshooting can become reactive, inefficient, and prone to overlooking critical underlying issues, leading to prolonged downtime and increased costs. Correct approach analysis. The correct approach involves a methodical, layered investigation that begins with gathering comprehensive data and progressively narrows down potential causes. This aligns with best practices in IT service management and network troubleshooting, emphasizing a top-down or bottom-up approach based on initial observations. Specifically, starting with user-reported symptoms and correlating them with network performance metrics e.g. signal strength, interference, client association data, provides a baseline for investigation. Utilizing Cisco's built-in diagnostic tools and logs, e.g. wireless controller logs, AP debugs, client trace captures, is crucial for identifying specific error messages, anomalies, or performance degradations. This systematic data collection and analysis allows for the isolation of the problem to a particular layer of the OSI model or a specific component, thereby enabling targeted remediation. This approach is professionally sound as it is efficient, minimizes disruption, and ensures that solutions are based on factual evidence rather than assumptions. It also adheres to the principle of least privilege and due diligence in IT operations, ensuring that changes are made only after thorough investigation. Incorrect approaches analysis. One incorrect approach involves immediately assuming a hardware failure and initiating component replacement without sufficient diagnostic data. This is professionally unacceptable because it is wasteful of resources, time, money, and personnel, and bypasses the critical step of verifying the problem. It can lead to unnecessary hardware costs and potentially introduce new issues if the replacement hardware is not properly configured or if the original problem was software-related. This approach fails to demonstrate due diligence and a systematic problem-solving process. Another incorrect approach is to focus solely on end-user devices and their configurations, neglecting the wireless infrastructure itself. While end-user issues can contribute to perceived network problems, a comprehensive troubleshooting process must consider the entire network path. Ignoring the wireless infrastructure means potentially missing critical issues like AP misconfigurations, interference sources, or controller problems that are directly impacting all users. This approach is ethically questionable as it fails to provide a complete and accurate assessment of the network's health, potentially leading to a misdiagnosis and an ineffective resolution. A third incorrect approach is to rely on anecdotal evidence or past experiences without validating current conditions. While experience is valuable, each network issue is unique. Assuming a problem is identical to a previous one without current data can lead to incorrect assumptions and wasted effort. This approach lacks the rigor required for effective troubleshooting and can be seen as unprofessional due to its reliance on guesswork rather than empirical evidence. It fails to meet the professional standard of thorough investigation and data-driven decision-making. Professional reasoning. Professionals should adopt a structured troubleshooting methodology, such as the OSI model or a similar layered approach, to systematically isolate the root cause of network issues. This involves clearly defining the problem, gathering relevant data from all potential sources, user reports, network devices, logs, analyzing the data to form hypotheses, testing those hypotheses and implementing and verifying solutions. When faced with intermittent issues, it is crucial to capture data during the periods when the problem is occurring. Documenting all steps taken and findings is also essential for knowledge sharing and future reference. This methodical process ensures that resources are used efficiently and that the most effective and lasting solutions are implemented. Question 13. The risk matrix shows a high probability of client connectivity issues impacting critical business operations, with a moderate impact on data integrity if left unresolved. A network administrator is tasked with restoring connectivity for affected users, which approach best balances immediate restoration with long-term network health and security. Option A. Escalate the issue to a senior engineer without performing any initial troubleshooting steps to avoid making the problem worse. Option B. Implement a temporary workaround by disabling a specific security feature on the APs to allow clients to connect, with plans to investigate the root cause later. Option C. Conduct a thorough diagnostic analysis, including reviewing AP logs, client connection states, and controller configuration, to identify the root cause before applying a permanent fix. Option D. Immediately revert the affected access points app to a previous known good configuration without further investigation. Correct answer is D. Immediately revert the affected access points app to a previous known good configuration without further investigation. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless troubleshooting, balancing immediate operational needs with long-term network stability and security. The pressure to restore service quickly can lead to hasty decisions that might introduce new vulnerabilities or violate established best practices. The professional challenge lies in navigating this pressure while adhering to the principles of sound network management and regulatory compliance, ensuring that the solution is not only effective but also secure and sustainable. Correct approach analysis. The correct approach involves a systematic, documented process that prioritizes understanding the root cause before implementing a fix. This aligns with best practices for network troubleshooting, emphasizing a methodical investigation that includes verifying configurations, checking logs, and consulting documentation. In the context of Cisco wireless enterprise networks, this means leveraging tools like the Cisco Prime Infrastructure or Cisco DNA Center for diagnostics, and ensuring any changes are logged and reviewed against security policies. This approach minimizes the risk of introducing new issues, ensures compliance with internal security policies, and potentially external regulatory requirements. Though none are specified for this exam, the principle of due diligence applies and provides a clear audit trail. It upholds the professional responsibility to maintain a secure and reliable network infrastructure. Incorrect approaches analysis. Implementing a quick workaround without thorough investigation is professionally unacceptable because it bypasses critical diagnostic steps. This can lead to a recurrence of the problem, mask underlying issues, or introduce security vulnerabilities. From a regulatory or ethical standpoint, this approach demonstrates a lack of due diligence and a failure to adhere to established IT governance principles, which often mandate documented troubleshooting processes and risk assessments. Applying a generic fix based on past experience without validating the current context is also professionally unsound. While experience is valuable, each network issue can have unique contributing factors. This approach risks misdiagnosing the problem and applying an inappropriate solution, potentially causing further disruption or security breaches. It fails to meet the professional standard of thoroughness and can be seen as negligent if it leads to adverse outcomes. Ignoring potential security implications to restore service is a critical regulatory and ethical failure. In enterprise environments, security is paramount. Any troubleshooting or remediation that compromises security, even temporarily, can lead to data breaches, compliance violations, and significant reputational damage. Best professional practice dictates that security considerations must be integrated into every step of the troubleshooting process. Professional reasoning. Professionals should approach troubleshooting by first establishing a clear understanding of the problem through data collection and analysis. This involves utilizing available diagnostic tools, reviewing logs, and consulting network documentation. Next, they should formulate hypotheses about the root cause and test them systematically. Any proposed solution should be evaluated for its potential impact on network stability, security, and performance. Implementation should be followed by verification and documentation. This structured approach, often referred to as the ITIL framework or similar methodologies, ensures that solutions are effective, sustainable, and compliant with organizational policies and industry best practices. Question 14. The risk matrix shows that intermittent wireless performance degradation has a moderate impact but a high likelihood of occurrence. A user reports experiencing slow Wi-Fi speeds and dropped connections, but these issues are not consistently reproducible. Which troubleshooting approach best aligns with professional best practices for resolving such a scenario? Option A. Systematically gather historical performance data from the wireless controller and access points, correlate it with the user's reported times and locations, and utilize diagnostic tools to analyze RF conditions, interference, and client roaming behavior. Option B. Advise the user to simply move to a different location within the building, as this often resolves intermittent wireless problems by finding a better signal area. Option C. Immediately replace the access point in the user's vicinity, assuming it is the source of the problem due to the intermittent nature of the reported issues. Option D. Focus exclusively on reconfiguring the user's client devices, wireless adapter settings, and reinstalling drivers, as client-side issues are often the cause of intermittent connectivity. The correct answer is C. Immediately replace the access point in the user's vicinity, assuming it is the source of the problem due to the intermittent nature of the reported issues. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless troubleshooting, the intermittent nature of performance degradation. The risk matrix highlights that while the impact of poor Wi-Fi performance is moderate, the likelihood of it occurring is high, indicating a critical need for proactive and effective troubleshooting. The difficulty lies in isolating the root cause when issues are not consistently reproducible, potentially impacting user productivity and business operations without a clear, immediate trigger. This requires a systematic approach that goes beyond superficial checks and delves into the underlying network behavior. Correct approach analysis. The best professional practice involves a multi-layered, data-driven troubleshooting methodology. This begins with validating the client's reported experience, and then systematically examining the wireless infrastructure from the client perspective up to the core network. Leveraging Cisco's Wireless Control System, WCS, or newer DNA Center for centralized visibility, and utilizing tools like the Cisco Wireless Diagnostics and Troubleshooting Utility, CDT, or packet captures, PCAP, on the client and access points are crucial. Analyzing historical data for trends in signal strength, interference, channel utilization, client roaming behavior, and AP load provides context. Correlating these findings with the client's specific location and time of reported issues allows for the identification of potential culprits such as RF interference, suboptimal channel planning, AP coverage gaps, or client-specific issues. This methodical approach ensures that all potential factors are considered, leading to an accurate diagnosis and a sustainable resolution, aligning with the professional obligation to provide reliable network services. Incorrect approaches analysis. One incorrect approach is to immediately assume a hardware failure of the access point without sufficient evidence. This bypasses critical diagnostic steps, potentially leading to unnecessary hardware replacement costs and extended downtime if the issue is software-related, configuration-based, or environmental. This failure to conduct thorough analysis violates the principle of efficient resource utilization and can lead to a recurrence of the problem if the true root cause is not addressed. Another incorrect approach is to focus solely on the client device's configuration without considering the wireless environment. While client-side issues can contribute, neglecting the RF environment, AP configurations, or network infrastructure can lead to misdiagnosis. This approach fails to acknowledge the complex interplay between client devices and the wireless network, potentially leaving the core problem unresolved and impacting other users. A third incorrect approach is to rely solely on anecdotal user reports without objective data collection. While user feedback is valuable, it can be subjective and lack the precision needed for effective troubleshooting. Without correlating these reports with network performance metrics, logs, and diagnostic data, it's easy to chase symptoms rather than causes, leading to inefficient use of troubleshooting resources and a lack of confidence in the resolution. This can also lead to a perception of unreliability in the network services provided. Professional reasoning. Professionals should adopt a structured troubleshooting framework. This typically involves 1. Understanding the problem, gathering information, user reports. 2. Isolating the problem, identifying the scope and affected components. 3. Identifying the cause, collecting data, analyzing logs using diagnostic tools. 4. Testing the solution, implementing changes and verifying resolution. 5. Documenting the solution, recording findings and actions taken. In situations with intermittent issues, a strong emphasis on data collection and historical analysis is paramount. Professionals must be adept at using network management tools and diagnostic utilities to capture and interpret relevant data, ensuring that decisions are based on objective evidence rather than assumptions. Question 15. Governance review demonstrates that intermittent client connectivity issues are frequently reported across multiple departments. A recent incident involved a critical sales team losing Wi-Fi access for several hours, impacting their ability to access cloud-based CRM systems. The IT team needs to implement a more robust and efficient troubleshooting strategy to address these recurring problems. Which of the following approaches best aligns with industry best practices for diagnosing and resolving such issues in a Cisco wireless enterprise network? Option A. Immediately initiate a deep packet inspection analysis on the wireless controller for all affected client MAC addresses to identify any anomalies in traffic patterns. Option B. Systematically verify client-side issues, e.g., driver updates, signal strength on the client device. Then examine AP health and client association logs on the controller, and finally investigate broader network connectivity before escalating to controller-level configuration changes. Option C. Conduct a comprehensive site survey of all affected areas to identify potential RF interference sources, and then reconfigure AP channel assignments and power levels across the entire network. Option D. Implement a new firmware version on all access points and the wireless controller to address potential bugs that may be causing instability. The correct answer is A. Immediately initiate a deep packet inspection analysis on the wireless controller for all affected client MAC addresses to identify any anomalies in traffic patterns. Explanation: Scenario analysis. This scenario presents a common challenge in enterprise wireless troubleshooting: the difficulty in isolating the root cause of intermittent client connectivity issues. The challenge lies in the distributed nature of wireless networks, the multitude of potential failure points, client devices, access points, controllers, network infrastructure, environmental factors, and the transient nature of the problem, making it hard to reproduce and diagnose. Professionals must balance the urgency of restoring service with the need for thorough, systematic investigation to avoid premature conclusions and wasted effort. The pressure to resolve the issue quickly can lead to hasty decisions, potentially overlooking critical evidence or implementing ineffective workarounds. Correct approach analysis. The correct approach involves a methodical, layered troubleshooting methodology, starting with the most probable and easily verifiable causes and progressively moving to more complex ones. This aligns with best practices in IT service management and network engineering, emphasizing a structured problem-solving process. Specifically, beginning with client-side checks, driver updates, signal strength, interference on the client device itself, and then moving to the immediate wireless infrastructure, AP health, client association logs, controller logs, before investigating broader network issues is the most efficient and effective way to isolate the problem. This approach minimizes disruption, reduces the likelihood of misdiagnosis, and ensures that foundational elements are validated before delving into more intricate configurations or hardware. This systematic process is ethically sound as it prioritizes accurate diagnosis and efficient resolution, respecting user productivity and organizational resources. Incorrect approaches analysis. One incorrect approach is to immediately assume a controller-level configuration issue without first verifying the client and AP health. This is a regulatory and ethical failure because it bypasses fundamental troubleshooting steps, potentially leading to unnecessary and disruptive changes to the core network infrastructure. It wastes valuable time and resources that could have been spent on simpler, more probable causes. Another incorrect approach is to focus solely on RF interference analysis without considering client-specific issues or AP operational status. While RF is a critical factor, neglecting client-side problems, e.g., faulty NIC, outdated drivers, or AP malfunctions, e.g., hardware failure, overloaded AP, is a failure to conduct a comprehensive investigation. This can lead to misattributing the problem and implementing solutions that do not address the actual root cause, thereby failing to meet service-level expectations and potentially violating service agreements. A third incorrect approach is to implement a blanket policy change across all APs without isolating the affected APs or clients. This is a significant operational and ethical risk, as it can negatively impact a much larger user base than necessary, causing widespread disruption and potentially violating change management protocols. It demonstrates a lack of due diligence and a failure to apply the principle of least impact. Professional reasoning. Professionals should adopt a structured troubleshooting framework, often referred to as the bottom-up or layered approach. This involves starting with the physical layer and moving upwards through the OSI model or a similar network model. For wireless, this translates to 1. Client device verification, physical connection, drivers, OS. 2. Wireless medium, RF environment, interference, signal strength. 3. Access point app, status and configuration. 4. Wireless controller, WLC status and configuration. 5. Wired network infrastructure connecting APs to the controller and beyond. This systematic process ensures that each layer is validated before proceeding, preventing wasted effort and misdiagnosis. When faced with intermittent issues, meticulous log analysis at each stage is crucial, correlating timestamps and events across client, app, and controller logs. Documenting each step taken and its outcome is also vital for knowledge sharing and future reference, adhering to IT best practices and audit requirements. Question 16. Market research demonstrates a growing industry trend towards adopting WPA3 for enhanced wireless security. Your organization, operating under U.S. federal regulations for data protection, is considering a network-wide upgrade. You have a diverse range of client devices, some of which may not natively support WPA3. What is the most professionally responsible approach to implementing WPA3 across your enterprise wireless network? Option A. Conduct thorough compatibility testing with a representative sample of client devices and access points, followed by a phased rollout starting with a pilot group and gradually expanding to the entire network. Option B. Postpone the WPA3 upgrade indefinitely, continuing to rely on WPA2 with strong pre-shared keys, as it is still widely used. Option C. Immediately enable WPA3 on all access points to ensure the highest level of security across the entire network as quickly as possible. Option D. Deploy WPA3 only on newly purchased access points, leaving existing infrastructure on WPA2 to avoid immediate disruption. The correct answer is A. Conduct thorough compatibility testing with a representative sample of client devices and access points, followed by a phased rollout starting with a pilot group and gradually expanding to the entire network. Explanation. Scenario analysis. This scenario presents a common implementation challenge in enterprise wireless networks, ensuring consistent and secure client connectivity across diverse locations while adhering to evolving security standards. The professional challenge lies in balancing the immediate need for network access with the long-term implications of security vulnerabilities and potential compliance breaches. The rapid adoption of new security protocols, like WPA3, necessitates a proactive approach to network upgrades, but the practicalities of large-scale deployments, including compatibility testing, user impact, and resource allocation, require careful planning and execution. The pressure to deliver a functional network quickly can sometimes lead to shortcuts that compromise security or future scalability. Correct approach analysis. The correct approach involves a phased rollout strategy that prioritizes security and user experience. This begins with thorough compatibility testing of WPA3 on a representative sample of client devices and access points. Following successful testing, a pilot deployment in a controlled environment allows for real-world validation of performance and security policies. The subsequent staged rollout, starting with less critical areas and gradually expanding, minimizes disruption and allows for iterative refinement of the deployment process. This approach aligns with best practices for network security and change management, ensuring that security enhancements are implemented effectively without causing widespread service degradation. It also demonstrates a commitment to maintaining a secure and compliant network infrastructure, which is a fundamental ethical and professional responsibility. Incorrect approaches analysis. Implementing WPA3 across all access points simultaneously without prior compatibility testing poses a significant risk of widespread client connectivity issues. This could lead to a denial of service for users, impacting business operations and potentially violating service-level agreements. From a regulatory perspective, if the organization is subject to data protection regulations, e.g., GDPR if operating in the EU or similar frameworks, a widespread network outage due to an unvetted security upgrade could be seen as a failure to maintain adequate security measures, potentially leading to noncompliance. Deploying WPA3 only on new access points while leaving existing ones on older security protocols creates a fragmented security posture. This security by obscurity approach leaves the network vulnerable to attacks that exploit weaknesses in the older protocols. It also creates an inconsistent user experience and can be challenging to manage and monitor effectively. Ethically, it represents a failure to provide a uniformly secure environment for all users and data. Ignoring WPA3 adoption altogether and continuing with WPA2 indefinitely, even with strong passphrases, is a direct contravention of evolving security best practices and industry recommendations. As WPA2 vulnerabilities become more widely known and exploited, maintaining an outdated security standard exposes the organization to significant risks of data breaches and unauthorized access. This inaction could be viewed as negligent from a professional standpoint and could lead to severe regulatory penalties if a breach occurs due to the known weaknesses of WPA2. Professional reasoning. Professionals should approach network implementation challenges by prioritizing a structured, risk-aware methodology. This involves understanding the business impact of any proposed change, thoroughly researching and testing new technologies, and developing a phased deployment plan that includes rollback strategies. Continuous monitoring and user feedback are crucial throughout the process. When dealing with security upgrades, the decision-making process must be guided by industry best practices, vendor recommendations, and relevant regulatory requirements, ensuring that security is not compromised for the sake of expediency. A proactive stance on security, coupled with a methodical implementation, is the hallmark of professional responsibility. Question 17. Assessment of the most effective strategy for introducing WPA3 enterprise security to an existing Cisco wireless network environment, considering the need to maintain seamless client connectivity and minimize user impact during the transition. Option A. Proceed with the WPA3 enterprise implementation without verifying compatibility with existing client devices, assuming they will adapt. Option B. Immediately deploy WPA3 enterprise across all access points and client configurations to ensure uniform security posture. Option C. Conduct a phased rollout, starting with a pilot deployment on a non-critical network segment to identify and resolve compatibility issues before a full-scale implementation. Option D. Implement WPA3 enterprise exclusively in a dedicated, isolated test lab environment that does not mirror the production network's complexity. Correct answer is C. Conduct a phased rollout, starting with a pilot deployment on a non-critical network segment to identify and resolve compatibility issues before a full-scale implementation. Explanation. Scenario analysis. This scenario presents a common yet challenging implementation hurdle in enterprise wireless networks: the integration of a new wireless security protocol without disrupting existing client connectivity. The professional challenge lies in balancing the imperative to enhance security with the operational requirement of maintaining uninterrupted service for users. A misstep can lead to widespread user complaints, lost productivity, and potential security vulnerabilities if the new protocol is implemented insecurely or incompletely. The need for careful planning, phased rollout, and thorough testing is paramount. Correct approach analysis. The correct approach involves a phased implementation strategy, beginning with a pilot deployment on a non-critical segment of the network. This allows for real-world testing of the new security protocol, e.g., WPA3 enterprise, in a controlled environment. It enables the identification and resolution of any compatibility issues with specific client devices or applications before a full-scale rollout. This methodical approach minimizes risk, ensures a smoother transition, and aligns with best practices for network change management, which implicitly support operational continuity and data integrity as per general IT governance principles. Incorrect approaches analysis. Implementing the new security protocol across the entire network simultaneously without prior testing is a significant regulatory and ethical failure. It disregards the principle of due diligence in network management, potentially leading to a widespread service outage. This failure to adequately plan and test can be seen as a breach of the implicit duty of care to maintain network availability and security. Deploying the new protocol only on a small, isolated test lab that does not accurately reflect the production environment is also professionally unacceptable. While it involves some testing, the lack of realism in the test environment means that critical integration issues specific to the live network's configuration, client diversity, and traffic patterns may go undetected. This incomplete testing can lead to unexpected failures during the production rollout, violating the expectation of a reliable and secure network. Ignoring existing client device compatibility and proceeding with the implementation without verifying support for the new security protocol is a direct contravention of responsible network deployment. It prioritizes a technical objective over user experience and operational stability, potentially rendering a significant portion of the user base unable to connect. This demonstrates a lack of foresight and a failure to consider the impact of network changes on end users, which is a core tenet of professional IT service delivery. Professional reasoning. Professionals should approach network implementation challenges by first conducting a thorough risk assessment, identifying potential impacts on users and operations. This should be followed by a detailed planning phase that includes a phased rollout strategy, comprehensive testing protocols, including pilot deployments and compatibility checks, and a rollback plan. Communication with stakeholders, including end users, about planned changes and potential impacts is also crucial. The decision-making process should prioritize minimizing disruption, ensuring security, and maintaining service availability, adhering to established IT governance and operational best practices. Question 18. Comparative studies suggest that following a recent enterprise-wide wireless firmware upgrade, users are reporting intermittent and unpredictable roaming failures between access points app, leading to dropped connections. The network engineering team has observed that the issue began immediately after the upgrade was completed across all APs. What is the most prudent and professionally responsible approach to diagnose and resolve this roaming degradation? Option A. Initiate a full network-wide rollback of the wireless firmware to the previous stable version immediately to restore service as quickly as possible. Option B. Roll back the firmware on a small, representative subset of access points to the previous stable version and monitor roaming performance for those APs. If successful, gradually expand the rollback to the rest of the network. Option C. Focus troubleshooting efforts exclusively on client devices, checking their wireless drivers, network adapter settings, and roaming capabilities. Option D. Reconfigure roaming parameters such as roaming aggressiveness and inter-AP communication settings on all access points to attempt to compensate for the perceived issue. The correct answer is B. Roll back the firmware on a small, representative subset of access points to the previous stable version and monitor roaming performance for those APs. If successful, gradually expand the rollback to the rest of the network. Explanation. Scenario analysis. This scenario presents a common yet challenging implementation hurdle in enterprise wireless networks: the unexpected degradation of client roaming performance after a seemingly routine firmware upgrade. The challenge lies in the intermittent and user-impacting nature of the problem, making it difficult to isolate the root cause. The pressure to restore full functionality quickly, coupled with the potential for widespread user dissatisfaction and productivity loss, necessitates a systematic and informed troubleshooting approach. The complexity is amplified by the need to consider not just the immediate fix, but also the long-term stability and adherence to best practices, all within the operational constraints of a live enterprise environment. Correct approach analysis. The correct approach involves a methodical rollback of the firmware to the previous stable version on a subset of access points, app, and then observing the roaming performance. This is best professional practice because it directly addresses the most probable cause identified, the firmware upgrade, in a controlled manner. By isolating the rollback to a subset, the impact of a failed rollback is minimized, allowing for a quick reversion if the issue persists. This iterative and controlled testing methodology is crucial for maintaining network stability and user experience. It aligns with professional ethics by prioritizing the restoration of service with minimal disruption, and by employing a data-driven approach to problem resolution. This method adheres to the principle of least change and allows for clear cause and effect analysis. Incorrect approach is analysis. Implementing a full network-wide rollback without prior testing on a subset of APs is a regulatory and ethical failure because it introduces a significant risk of widespread service disruption if the rollback itself is problematic or if the original issue was not solely firmware-related. This all-or-nothing approach lacks the controlled validation required for enterprise-level changes and can lead to a worse situation than the initial problem. Attempting to reconfigure roaming parameters on all APs without first reverting the firmware is an incorrect approach because it fails to address the most likely culprit identified by the timing of the issue. This is a failure of professional reasoning, as it bypasses the most direct diagnostic step. It risks wasting valuable troubleshooting time on secondary or unrelated configurations, while the primary issue remains unaddressed, potentially leading to prolonged user impact and a breach of service-level expectations. Focusing solely on client-side troubleshooting without considering the network infrastructure is an incorrect approach because the problem manifested immediately after a network-wide change. This demonstrates a failure to consider the entire system and its interconnected components. It is professionally unsound to assume the issue lies with the clients when the trigger was a network infrastructure update, leading to inefficient resource allocation and delayed resolution. Professional reasoning. Professionals should approach such implementation challenges by first establishing a clear baseline of the network's performance prior to the change. When an issue arises post-implementation, the immediate focus should be on the most recent change as the primary suspect. A structured troubleshooting methodology, such as the OSI model or a similar layered approach, should be employed. This involves hypothesizing potential causes, designing controlled tests to validate or invalidate these hypotheses, and implementing solutions incrementally. Prioritization should always be given to solutions that minimize risk and maximize the likelihood of a swift and accurate resolution. Documentation of all steps taken, observations, and outcomes is critical for future reference and for demonstrating due diligence. Question 19. Strategic planning requires a robust methodology for addressing intermittent wireless client connectivity disruptions. Given a scenario where multiple users across different building floors report sporadic disconnections from the corporate Wi-Fi network, which of the following approaches best aligns with efficient and effective troubleshooting practices within a Cisco wireless enterprise environment? Option A. Immediately initiate a widespread replacement of access points in the affected areas, assuming a hardware failure is the most probable cause of the intermittent connectivity. Option B. Systematically analyze controller logs, client connection history, and wireless event logs, correlating findings with user reports and leveraging Cisco Prime Infrastructure or Cisco DNA Center for historical data and performance insights. Option C. Focus exclusively on updating client wireless drivers and reinstalling network adapters on affected user devices, as client-side issues are often the primary culprit for such problems. Option D. Implement broad, network-wide configuration changes, such as adjusting RF power levels or channel assignments across all access points, to see if any change resolves the issue. The correct answer is B. Systematically analyze controller logs, client connection history, and wireless event logs, correlating findings with user reports and leveraging Cisco Prime Infrastructure or Cisco DNA Center for historical data and performance insights. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless network troubleshooting, intermittent client connectivity issues that are difficult to reproduce and diagnose. The difficulty lies in the transient nature of the problem, making it hard to capture relevant data or replicate the exact conditions under which the issue occurs. This requires a systematic and thorough approach, moving beyond superficial checks to deeper analysis of network behavior and client interactions. The professional challenge is to balance the urgency of resolving user-impacting issues with the need for accurate diagnosis and avoiding unnecessary or disruptive changes. Correct approach analysis. The correct approach involves a multifaceted investigation that begins with gathering comprehensive information from the affected users and then systematically analyzing the wireless infrastructure. This includes examining controller logs, client connection history, and wireless event logs for patterns or anomalies that correlate with the reported connectivity drops. Utilizing Cisco Prime Infrastructure or Cisco DNA Center for historical data analysis, performance metrics, and proactive alerting is crucial. This method represents best professional practice because it is data-driven, systematic, and leverages the diagnostic capabilities of the Cisco wireless ecosystem. It adheres to the principles of efficient troubleshooting by first understanding the scope and nature of the problem before implementing solutions. From a regulatory perspective, ensuring reliable network access is often an implicit requirement for business operations, and a structured troubleshooting methodology helps maintain service levels, which can be indirectly linked to compliance with service level agreements (SLAs) or industry standards for network availability. Incorrect approaches analysis. One incorrect approach is to immediately assume a hardware failure and begin replacing access points or controllers without sufficient diagnostic evidence. This is professionally unacceptable as it is wasteful, disruptive, and does not address the root cause if the issue is software-related, configuration-based, or environmental. Fails to adhere to a logical troubleshooting methodology and can lead to further instability. Ethically, it represents a failure to exercise due diligence and responsible resource management. Another incorrect approach is to focus solely on client-side issues, such as updating drivers or reinstalling network adapters, without investigating the wireless network's health. While client issues can contribute, neglecting the infrastructure side means missing potential problems with AP configuration, controller load, interference, or roaming issues. This approach is incomplete and can lead to prolonged downtime for users. It fails to meet the professional standard of a holistic network investigation. A third incorrect approach is to make broad, sweeping configuration changes across the wireless network in an attempt to fix the problem, without understanding the specific impact of each change. This is highly risky, can introduce new problems, and makes it impossible to isolate the actual cause of the original issue. It violates the principle of making controlled, incremental changes and demonstrates poor professional judgment. It also carries a regulatory risk if such changes inadvertently violate network security policies or compliance requirements. Professional reasoning. Professionals should adopt a structured troubleshooting methodology, often referred to as the bottom-up or top-down approach, adapted to the specific problem. This involves clearly defining the problem, gathering information, hypothesizing potential causes, testing hypotheses through controlled experiments and data analysis, and implementing solutions. For wireless networks, this means leveraging the diagnostic tools provided by the vendor, e.g., Cisco WLC Logs Prime DNA Center, to analyze historical and real-time data. When faced with intermittent issues, patience and meticulous data collection are key. Professionals should always document their steps, findings, and changes made. This systematic approach ensures that solutions are effective, efficient, and minimize disruption, aligning with professional responsibility and ethical conduct. Question 20. To address the challenge of ensuring seamless and secure client roaming across newly implemented, security-segmented Cisco wireless access point groups, what is the most professional and effective approach to validate the configuration before a full production rollout? Option A. Implement the new AP group configuration and only test client association with APs within the new group, without validating intergroup roaming. Option B. Deploy the new AP group configuration and immediately proceed with user acceptance testing, assuming roaming will function correctly. Option C. Conduct thorough roaming tests between the existing and new AP groups, verifying client IP address, VLAN, and access control list, ACL, enforcement as clients transition. Option D. Deploy the new AP group configuration across the entire network, without any specific roaming validation tests between AP groups. The correct answer is C. Conduct thorough roaming tests between the existing and new AP groups, verifying client IP address, VLAN, and access control list, ACL, enforcement as clients transition. Explanation. Scenario analysis. This scenario presents a common implementation challenge in enterprise wireless networks, ensuring consistent and secure client roaming across different access point, app groups, particularly when these groups are segmented for security or performance reasons. The professional challenge lies in balancing the need for seamless connectivity with the strict security policies that dictate client access to specific network resources. Misconfiguration can lead to security breaches, denial of service for legitimate users, or a poor user experience, all of which have significant operational and reputational consequences. The complexity arises from the interplay of Layer 2 roaming, Layer 3 roaming, security policies, like ACLs and VLAN assignments, and the underlying network infrastructure. Correct approach analysis. The correct approach involves a phased deployment and rigorous testing strategy, focusing on validating the roaming behavior between AP groups. This includes verifying that clients successfully transition between APs in different groups without losing connectivity or violating security policies. Specifically, it requires confirming that the client's IP address, VLAN assignment, and access control lists, ACL, are correctly maintained or updated according to the security posture defined for the target AP group. This methodical approach ensures that the network functions as intended, adhering to security best practices and providing a reliable user experience. This aligns with professional best practices of thorough validation before full rollout, minimizing risk and ensuring compliance with established network security and operational standards. Incorrect approaches analysis. Deploying the new AP group configuration without comprehensive roaming tests between the existing and new AP groups is a significant regulatory and ethical failure. It bypasses essential validation steps, potentially exposing the network to security vulnerabilities if clients gain unauthorized access or if their traffic is misrouted. This directly contravenes the principle of maintaining network integrity and security, which is a fundamental ethical obligation for network professionals. Implementing the new AP group configuration and immediately assuming seamless roaming without any verification is also professionally unacceptable. This cavalier attitude towards network stability and security can lead to widespread service disruptions and security breaches. It demonstrates a lack of due diligence and a disregard for the potential impact on users and the organization's data. Focusing solely on the client's ability to associate with APs in the new group, while neglecting to test the actual roaming process and the associated security policy enforcement, is another critical failure. Association is only the first step. Successful roaming requires maintaining connectivity and adhering to security policies as the client moves between APs. Ignoring this crucial aspect can result in clients being able to access resources they should not, or conversely, being denied access to resources they are permitted to use, leading to both security risks and user frustration. Professional reasoning. Professionals should adopt a risk-based approach to network implementation. This involves identifying potential failure points, such as roaming between security zones, and developing a comprehensive testing plan to mitigate those risks. The decision-making process should prioritize security and user experience, ensuring that all configurations are validated against established policies and operational requirements before being deployed to the production environment. A structured approach, including pilot testing and phased rollouts, is essential for managing complexity and ensuring successful outcomes.